In question 1 of this exercise, we have to find the sum of the following APs. So we are given 4 APs, and for each AP we are given the first 3 terms, and we have to find the sum of that AP up to the specified number of terms. So the formula we are going to use to calculate the sum of terms in each case is Sn, the sum of n terms, is equal to n by 2 times 2a plus n minus 1 times d. This is the formula that we're going to use because we have the first term for each AP, we have the common difference for each AP, and we have the number of terms up to which the sum has to be calculated. Okay, so let's start with the first part. So in the first part, the AP is 2, 7, 12 and so on, and we have to sum it up to 10 terms. So for this AP, the first term A is 2, the common difference D can be taken as a difference of any pair of successive terms, consecutive terms. So D is 5, and we have to sum this AP up to 10 terms. So n is equal to 10. And now we will plug these values into this formula for Sn, or S10 in this case. So S10 will be equal to n by 2. So that's 10 by 2 into 2a. So 2 into 2 plus n minus 1 into d. So n is 10. So n minus 1 is 9. So 9 into d is 5. So this is what we get as the expression for S10. So this is equal to 5, and inside the bracket we get 2 into 2 is 4, and 9 into 5 is 45. So 4 plus 45 is 49. So 5 into 49, this is equal to 245. So the sum of the first AP up to 10 terms is 245. Now let's do the fourth part. So in the fourth part, the AP is 1 by 15, 1 by 12, 1 by 10 and so on, and we have to sum it up to 11 terms. Now the first 3 terms are fractions, and it's hard to make out that this is an AP. And it's not directly clear that this is an AP, but if you rewrite the first 3 terms with a common denominator, you will see that it is actually an AP. So the LCM of 15, 12 and 10 is 60. So if you write all 3 terms with the denominator 60, what do you get? So the first term 1 by 15 can be written as 4 by 60. Then the next term 1 by 12 can be written as 5 by 60. And then 1 by 10 can be written as 6 by 60. So now it's immediately clear that this is an AP, and this AP has its first term as 4 by 60 or 1 by 15. The common difference D is the difference between any pair of consecutive terms. So we can see that this is equal to 1 by 60. And now we have to sum this AP up to 11 terms. So n is equal to 11. So let's apply the formula. So S11, the sum of 11, the first 11 terms will be equal to n by 2. So 11 by 2 into 2a. So 2 into 1 by 15 or 2 by 15 plus n minus 1 into d. So n is 11. So n minus 1 is 10 into d is 1 by 60. So this is what we get. So we have 11 by 2 into 2 by 15 plus 1 by 6. So now 2 by 15 plus 1 by 6, we can take the LCM of 15 and 6 and add these 2 fractions. So this will be equal to 9 by 30. So we get 11 by 2 into 9 by 30, and this in the simplest form. So if we cancel out common factor of 3, so we get 3 by 10. So 11 into 3 is 33 and 2 into 10 is 20. So we get 33 by 20. So I'm going to write it here. 33 by 20 is the value of S11. So the sum of the AP in the fourth part up to for the first 11 terms is 33 by 20. And with that, all 4 parts of question 1 are done. Exercise, we have to find the 3 sums given below. So we have these 3 arithmetic progressions, and in each case we are given the first 3 terms and the last term of the arithmetic progression, and we have to find the sum of terms. So we don't have the number of terms, but what we do have is the first term and the last term, and of course we can find the common difference in each case. So there are two formulas that help us find the sum of terms of an arithmetic progression. So here are those two formulas. So the first one is Sn equal to n by 2 into 2a plus n minus 1 times d. This helps, this formula can be used if we have the number of terms, the first term and the common difference, and the other formula is Sn is equal to n by 2 times a plus l, where n is again the number of terms, a is the first term and l is the last term. So in this case what we will do is, because we don't have the number of terms, we will first find the number of terms for each case, and then we will use this second formula to find the sum of terms. Okay, so let's start with the first part. So in the first part, the sum that we have to find is 7 plus 10.5 plus 14 all the way up to 84. So first we'll find the number of terms n. So to do that, we will use this relation for the nth term of an AP, Tn equal to a plus n minus 1 times d. So in this case 84 is the last term and we have to find its position, because that will give us the number of terms in the progression. So 84 is the last term, 7 is the first term, and the common difference is the difference between any pair of consecutive terms, so that's 3.5 in this case. So we are going to write 84, which is the nth term, is equal to a, the first term, plus n minus 1 times d, and d is 3.5 or 3.5. Okay, so now 84 minus 7 is 77, so 77 is equal to 3.5 times n minus 1, and from here we get n minus 1 is equal to 77 by 3.5. 77 by 3.5 is 22, so this means that n is equal to 23. So there are 23 terms in this progression of terms, and now that we have the number of terms, we can apply this formula for Sn equal to n by 2 times a plus l. So S23, or the sum of these 23 terms, is equal to 23 by 2 into a plus l. So what is a? So a is the first term, 7, and what is l? L is the last term, which is 84. So 23 by 2 into 7 plus 84, or 23 by 2 into 91. Now 23 by 91 is 2093. So 2093 by 2, this is equal to 1046.5. So this is our answer for the first part. The first sum is 1046.5. Now let's do part 2. So in part 2, the progression or the sum is 34 plus 32 plus 30, and this goes up to the term 10. So once again we'll first find the number of terms in this progression, and we will make use of this relation Tn is equal to a plus n minus 1 times d, where Tn is this last term 10. So we will write 10 is equal to a. What is a? A is the first term, 34, plus n minus 1 times d. Now what is d? So you take any pair of consecutive terms like 32 and 30, and you see that d is equal to minus 2. 30 minus 32, so that's minus 2. So from here we get 10 minus 34, or minus 24, is equal to minus 2 times n minus 1, and this gives us minus 24 by minus 2, that's 12. So 12 is equal to n minus 1, and from here we get n is equal to 13. So there are 13 terms in this progression, in this sum, and now we can apply this formula Sn equal to n by 2 times a plus l to find the sum of these 13 terms. So we will get S13. The sum of these 13 terms will be 13 by 2 into A plus L. So what is A? A is 34 and L is 10. So 34 plus 10. And now we get 13 by 2 into 34 plus 10 is 44. And then we get 13 into, so we get, if we divide by 2, we get 22. So 13 times 22, and 13 times 22 is 286. So the sum in part 2 is equal to 286. So that completes part 2. Now let's do part 3. So this exercise is kind of a long question. There are 10 parts in this question. In each part, we are given some parameters of an arithmetic progression and we have to find some other parameters. So let's go one by one and solve each question. So in the first question, in the first part, we are told that the AP has A equal to 5, the first term equal to 5, D, the common difference is 3, and the nth term is 50. And we have to find n, and then we have to find Sn, the sum of these n terms. So let's use the relation Tn, the nth term, or actually in this case we can write An. So An is equal to the first term A plus n minus 1 times D. So let's plug in the values. So An is 50, the nth term is 50, the first term is 5, and then we have n minus 1 into D is 3. D is also given to us. So from here we get 50 minus 5, so that's 45 is equal to 3 times n minus 1, and from here we get n minus 1 is 45 by 3, that's 15, or n is equal to 16. So n is equal to 16, and now we can find Sn, the sum of n terms. So that will be equal to, we'll use the formula n by 2 times 2a plus n minus 1 times d. We could use the other formula also, which is n by 2 times 2a times a plus l, or in this case a plus the last term al or an. But let's use this formula. So we will get 16 by 2 into 2a. So a is 5, so 2a is 10, plus n is 16, so n minus 1 is 15. 15 into d is 3, so that's 15 into 3 is 45. So this is what we get, 16 by 2 into 10 plus 45, or 8 into 55. And 8 into 55 is 440. So the answer to part 1 is that n is equal to 16 and Sn is equal to 440. So that completes part 1. Now let's do part 2. So in part 2, we are given that A is 17, the first term is 17, A 13, the 13th term is 35, and using this we have to find D, the common difference, and S13, the sum of the first 13 terms. So let's use again the relation An is equal to A plus n minus 1 times D, but in this case D is the unknown. So An is A13, so A13 is 35, A is 7, and n is 13, so n minus 1 is 12, so 12 into D. So this is the equation that we get. So 35 minus 7 is 28, so 28 is 12D, and from here we get the value of D. D is equal to 28 by 12, and if we reduce it to lowest form, we will get 7 by 3. So D is equal to 7 by 3. And now let's find S13, the sum of the 13 terms, the first 13 terms. So S13, let's use the formula n by 2 into a plus l, the last term. So n is 13, so 13 by 2 into a plus l. So a is 7 and the last term is 35. So 13 by 2 into 7 plus 35, or 13 by 2 into 42. So this is equal to 13 into 21, and this is equal to 273. So in the second part, the value of D is 7 by 3, and the value of S13 is equal to 273. So that completes part 2. Now let's go to part 3. In part 3, we are told that A12, the 12th term is 37, D is equal to 3, and we have to find A, the first term, and then we have to find S12, the sum of the first 12 terms. So again, we are going to first use the relation an equal to a plus n minus 1 times d, and a is the unknown in this case. So let's plug in the values. So an or a12 is equal to 37. This is equal to a plus n minus 1. So n is 12. So n minus 1 will be 11 into d will be equal to 3. D is given as 3. So we get 37 is equal to a plus 33, and from here we get a is equal to 37 minus 33 or 4. So the first term of the AP is 4. Now we will find S12, the sum of the first 12 terms. So to find this, we will make use of the formula n by 2 into a plus l. So S12 will be equal to 12 by 2 into a, the first term, which is 4, plus l, the last term or the 12th term in this case, which is 37. So this is what we get. So we get 12 by 2 is 6. So 6 into 4 plus 37 is 41, and this gives us 246. So the answer in part 3 is that a, the first term, is equal to 4, and S12, the sum of the first 12 terms, is equal to 246. So that completes part 3. Now let's do part 4. So in 6, we are given a equal to 2, the first term, d is equal to 8, and we are given Sn is equal to 90. And using this information, we have to find n and an. So let's make use of the relation Sn is equal to n by 2 into 2a plus n minus 1 times d. So we have Sn, we have a, we have d. What we don't have is n. So let's plug in the values and form an equation in n. So Sn is 90. So 90 is equal to n by 2 times 2a. So 2a is 4 plus n minus 1 into d. D is 8. So 8 into n minus 1. So this is the equation we get. So if we simplify the right side, we get n by 2 times 4 plus 8n. So 8 into n, let me write it as 8n, and then we get 8 into minus 1 is minus 8, minus 8 plus 4 is minus 4. So this is what I get on the RHS, and if I divide this bracket by 2, I get n into 4n minus 2. So this is what I get, and now let me multiply the expressions on the right side. So we get 4n square minus 2n. So the equation I get is 4n square minus 2n is equal to 90, and we still have a common factor of 2 on both sides. So let's divide by 2 on both sides. We will get 2n square minus n is equal to 45, or I can write this as minus 45 is equal to 0. So this is a quadratic equation in n, and now we can solve it using the quadratic formula and find the valid values of n. So n is equal to, I'm applying the quadratic formula now, so n is equal to minus b. So b is minus 1, so minus b is 1, plus minus root of b square, so that's 1, minus 4ac. Now a is 2 and c is minus 45. So we get 4 into 2, 8 into minus 45, that's minus 360. And we have a minus sign which will make this plus. So 1 plus 360 by 2a. So 2 into 2 is 4. So you can verify. If you want, you can pause the video for a minute and actually verify that this calculation is correct. And from here we get, under the root sign, we get 1 plus 360, that's root of 361, that's 19. So 1 plus minus 19 by 4. Now if you take the plus sign, you get the value 1 plus 19 by 4. So that's 20 by 4, or that is equal to 5. And if you take the minus sign, you get 1 minus 19 by 4. That is a non-integer value, and that does not work for n in this case, because n must be a positive integer. So the valid value of n for this part is n is equal to 5. And now the other thing we had to find was an or a5 in this case, that will be a plus n minus 1d or a plus 4d, and a is 2, so 2 plus 4 into d is 8, and this gives us 2 plus 32 or 34. So the answer to part 6 is that n is equal to 5 and a5, an or a5, the fifth term, is equal to 34. And make sure that you've understood this solution correctly. So by applying this relationship, we got a quadratic equation in n, and when we solved the quadratic equation, we got as always we got two roots. We got n equal to 5, and the other root we get is minus 18 by 4, which is a non-integer root, which does not work in this case. So that's why the answer for n is that n is equal to 5. So that completes part 6. Now let's go to part 7. In part 7, we are given a, the first term, is equal to 8. The nth term, an, is equal to 62, and sum of these n terms is equal to 210, and we have to find n and we have to find d. So the formula I'm going to use in this case is Sn is equal to n by 2 into a plus l, a plus the last term, or which I can write as a plus an. So we are given a, we are given an, and we are given Sn. So this will help us find the value of n. So let's plug in the values and see what we get. So Sn is 210. This is equal to n by 2 into a, which is 8, plus an, which is 62. So this is what we get. So we get 210 is equal to n by 2 into 8 plus 62 is 70. So n by 2 into 70, or 35n. And this means that n is equal to 210 by 35, which is equal to 6. So n is equal to 6, the number of terms is equal to 6. And now we can find d using the relationship an is equal to a plus n minus 1 times d. So if we plug in the values now, we will get, we have an is 62, a is 8, plus n is 6, so n minus 1 is 5, so 5d. And from here we get 62 minus 8 is 54, so 54 is equal to 5d, and hence d is equal to 54 by 5. This is equal to 54 by 5 will be equal to 10.8. So d is equal to 10.8. So the answer to part 7 is that n, the number of terms, is equal to 6, and d, the common difference, is equal to 10.8. So that completes part 7. Now let's do part 8. Okay, in part 8, what are we given? So we're given an is equal to 4, the nth term is 4, d, the common difference, is 2, and Sn, the sum of n terms, is equal to minus 14. And using this, we have to find n and a. So we don't have a, we don't have n, but we do have the common difference d, and we do have the nth term, and we do have the sum of terms up to the nth term. Okay, so let's first make use of the relation an in terms of a and d. So an is a plus n minus 1 times d. So this means that 4 is equal to a plus d is 2, so a plus 2 times n minus 1, or a plus 2n minus 2. So from here we can write a in terms of n, so a will be equal to 6 minus 2n. Okay, now let's make use of the fact that Sn is equal to minus 14. So Sn, the relation for Sn is n by 2 times a plus the last term or the nth term, so a plus an. And let's plug in the values. So minus 14 is equal to n by 2 times a plus an. Now an's value is known, an is equal to 4. But instead of a, what we can do is we can substitute this value of a that we've calculated in terms of n. So instead of a, let's write 6 minus 2n. And what this will do is this will give us an equation in n alone. So what will we get? So we will get minus 14 is equal to n by 2 times 6 plus 4 is 10. So 10 minus 2n. And if we divide by 2, we get n times 5 minus n. And if we now simplify it, we can rewrite this as a quadratic equation in n square minus 5n minus 14 equal to 0. And if you observe this quadratic expression on the LHS, it's quite easy to factorize. It can be factorized as n minus 7 times n plus 2. So the quadratic equation is n minus 7 times n plus 2 is equal to 0, and the only valid root is n equal to 7. So there are 7 terms in the AP in the progression, and now we can find the value of a. A is equal to 6 minus 2n, or 6 minus 14, or minus 8. So the answer to part 8 is that n, the number of terms, is equal to 7, and a, the first term, is equal to minus 8. So that completes part 8. Now let's go to part 9. In part, problem statement in question 4 of this exercise says, how many terms of the AP 9, 17, 25 and so on must be taken to give a sum of 636. So basically, as we take more terms of this AP, the sum will increase. For example, the sum of the first 2 terms will be 9 plus 17, which is 26. The sum of the first 3 terms will be 9 plus 17 plus 25, which will be higher, and so on. So if you take more and more terms of the AP, the sum will become higher and higher. And the question basically asks us to find how many terms should we take so that the sum becomes 636. So let's solve this problem step by step. So let's start by supposing that the number of terms to be taken, let's say that this is equal to n. And this basically means that Sn, the sum of the first n terms, must be equal to 636. Now we're going to use the relation for Sn in terms of a, n and d. So Sn, or the sum of n terms, can be written as n by 2 into 2a plus n minus 1 into d. So this is the relation we're going to use. So let's plug in the values into this relation. So we will get Sn, which we want to be 636. This will be equal to n by 2 into 2a. Now a is equal to 9, the first term. So 2a will be equal to 18, plus d is equal to the difference between any pair of consecutive terms. So d is equal to 8. So n minus 1 into 8, or 8 into n minus 1. And now if we simplify the right side, we get n by 2 into 18 plus 8n minus 8. And we can write this as n by 2 into 18 minus 8 is 10. So 8n plus 10. And if we divide the bracket by 2, we get n into 4n plus 5. And if I now multiply n with the bracket, I expand it, I will get 4n square plus 5n. So 4n square plus 5n is equal to 636. Let's write this as a standard form quadratic equation. So 4n square plus 5n minus 636 is equal to 0. And now if we solve this quadratic equation and find the value of n, we will get our answer. To solve this quadratic equation, I'm going to use the quadratic formula. So I'm going to first calculate the discriminant of this quadratic equation. So d is equal to b square minus 4ac, or 5 square minus 4 into a is 4, and c is minus 636. So this is what we get. So 5 square is 25, and we get minus 4 into 4 into minus 636, or plus 16 into 636. So you can check that the value of this expression is equal to 10,201, and this is the square of 101. So d is a perfect square. D is the square of 101. And now if we apply the quadratic formula to this quadratic equation, we get n is equal to minus b or minus 5 plus minus root d. So d is 101 square, so root d will be 101 by 2a. So a is 4, so 2a will be 8. So these are the two roots of n. If I take the plus sign, I get minus 5 plus 101 by 8, so that's 96 by 8. And if I take the minus sign, I get minus 5 minus 101 by 8, so I get minus 106 by 8. Now clearly this root is invalid because it gives us a non-integer, non-positive integer value of n. What we need is n to be a positive integer, which is what we get from this first root, 96 by 8, so this is equal to 12. So the only valid value for n is 12, and this means that 12 terms must be taken for the sum to be equal to 636. So the answer to this question is that 12 terms should be taken. Problem statement of question number 5 of this exercise. The first term of an AP is 5. So let's actually write this information as we read out the statement. So A is equal to 5. The last term is 45. So the last term L is 45. And the sum of terms is 400. So S is equal to 400. And we have to find the number of terms. So we have to find N. And we have to find the common difference. So we also have to find D. So we are going to first use the relation for S in terms of A and L because they are given to us, the first and the last term. So S is equal to N by 2 times A plus L. So this is what we're going to use, and this will give us the value of N. So let's plug in the values. So S is 400 equal to N by 2 times A plus L. So A is 5, L is 45, so 5 plus 45. So this is equal to N by 2 into 50, and this is equal to, if we divide by 2 we get 25, so we get 25N. So the equation we get in N is 25N is equal to 400. This means that N is equal to 400 by 25, that's equal to 16. So N is equal to 16, that means the number of terms in the AP is equal to 16. And now we can use the value of N and we can find the value of D. For that we are going to make use of the relationship nth term in terms of A, N and D. So nth term is A plus N minus 1 times D. In this case the nth term is the last term, which is 45. So 45 is equal to A, which is 5, plus N minus 1, N is 16, so N minus 1 is 15 into D, the common difference. So from here we get 45 minus 5, that's 40, so 40 is equal to 15D, and this means that D is equal to 40 by 15. And now if we reduce it to the lowest term, dividing by 5, dividing both the numerator and denominator by 5, we get 8 by 3. So D is equal to 8 by 3. So the answer to this question is that the number of terms is 16 and the common difference is equal to 8 by 3. Question 6 of the exercise, here's what the problem statement says. The first and last terms of an AP are 17 and 350 respectively. So the first term A is 17, the last term L is 350. Now if the common difference is 9, so the common difference is also given, so let's write it. So D is equal to 9. How many terms are there and what is their sum? So we have to find N, the number of terms, and we have to find Sn, the sum of those terms. So first let's find the number of terms by making use of the relationship An, the nth term is equal to A plus N minus 1 times D. In this case An is the last term L, so that's 350. This is equal to A, which is 17, plus N minus 1 into D. So D is 9, So 9 into n minus 1. So from here we get 9 into n minus 1 is equal to 350 minus 17, that's 333. So if I divide by 9 on both sides, I get n minus 1 is equal to 333 by 9, that's 37. And this means that n is equal to 38. So there are 38 terms in the AP. That solves part of the problem. Now we have to find their sum. So now we have to find S38. So to do that, I'm going to make use of the relation Sn is equal to n by 2 times a plus the last term an, or L if you want to write it as L. So S38 will be equal to 38 by 2 into a, which is 17, plus the last term L, or the 38th term, which is 350. And now if you calculate this, we will get 38 by 2 is 19 into 17 plus 350 is 367. So 19 into 367, this is equal to 6,973. So that completes the problem. The answer is that the number of terms is 38 and the sum of those terms is equal to 6,973. Problem statement in question 7 says, find the sum of the first 22 terms of an AP in which D is equal to 7. So the common difference D is equal to 7. And the 22nd term is 149. So A22, or the 22nd term, is equal to 149. And we have to find the sum of the first 22 terms, or S22. So this is what we have to find. So to do this, let's first find the first term of the AP. Let's assume that the first term is equal to A. And we are going to make use of the relation an. The nth term is equal to a plus n minus 1 into d. So an, or A22, is 149. This will be equal to a plus n minus 1 into d. D is 7. So 7 into n minus 1. And n is also known. N is 22. So a plus 7 into 22 minus 1, or 21. So we get 149 is equal to a plus 7 into 21, that's 147. And this means that a is equal to 149 minus 147, or 2. So the first term of the AP is equal to 2. Now it's straightforward to find S22. So for that purpose, we are going to make use of the relation Sn, the sum of n terms, is equal to n by 2 into a plus the last term, or the nth term. And this means that S22 will be equal to 22 by 2 into a plus the 22nd term. So a is 2, the 22nd term is 149, so 2 plus 149. So this is 22 by 2 is 11 into 2 plus 149 is 151. So 11 into 151, this is equal to 1661. So the answer to question 7 is that the sum of the first 22 terms, this sum is equal to 1661.
Thank you for watching our channel. இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்ததுன்னா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம இந்த சேனலை சப்ஸ்கிரைப் பண்ணிட்டு பக்கத்துல இருக்கக்கூடிய பெல் பட்டனை ட்ரைன்